The impacts of climate change are being felt around the world, from extreme weather events to biodiversity loss. We've been put on notice to take urgent action. Countries, including Australia, have committed to limiting global warming to well below 2 degrees above pre-industrial temperatures. But right now, we're on track for 2.1 to 3.5 degrees of warming by 2100. That's beyond what scientists consider manageable and could have potentially catastrophic impacts for the environment, people, and the economy.
So what we have is a world which is increasingly stressed by human activity.
The solution is to address the tens of billions of tons of greenhouse gases being pumped into the atmosphere every year. That requires not just dramatically reducing future emissions, but removing greenhouse gases already released.
This means drawing down or removing these historical emissions from the atmosphere for, if you like, geological time.
Natural systems such as our oceans and forests are highly effective carbon sinks, but they need help, especially given the further pressures from events such as bushfires and ocean warming. We don't yet have the right toolkit to effectively remove greenhouse gases at the scale required. So, the Australian Academy of Science brought together the country's leading experts to identify opportunities to expand research efforts and start the conversation in Australia. Beyond strengthening existing carbon sinks, new technologies will need to be developed.
I think the scale of the problem that we're facing means that we can't discount anything, and in fact, everything needs to be on the table.
Including things such as direct air capture, a technology that mimics trees.
We can develop these nanoporous materials that are really highly selective for capturing carbon dioxide from the atmosphere and other greenhouse gases. So in the same way that a tree uses photosynthesis, it takes in carbon dioxide and processes that carbon dioxide and spits out oxygen and energy at the other end, we've got a way to do that, if you like, using technology.
The first air capture units in Australia, designed by Southern Green Gas, are now in the prototype stage. But there are many other emerging technologies. This Hawaii-based startup, for example, uses solar power to make seawater less acidic, enabling the ocean to absorb more CO2. Scientists are now working to better understand the implications of the various emerging technologies.
There's a big gap between doing things at a lab base and doing them at a real-world scale significant enough to actually make a difference to climate change. That jump brings a whole series of uncertainties, risks and costs.
Once we have a better understanding of those consequences, the technologies could well be used alongside other strategies to help fight climate change.
I don't think there's any such thing as a silver bullet. So this is going to take a mammoth effort across the world, including a portfolio of approaches in order to get us to this point where we can indeed stabilise our climate and avoid a climate catastrophe.
Good morning and welcome everyone. I am Professor Chennupati Jagadish, President of the Australian Academy of Science. Thank you for joining us to launch Greenhouse Gas Removal in Australia, a report on the novel negative emissions approaches for Australia Roundtable. I firstly acknowledge and pay respect to the traditional owners of the lands on which the Australian Academy of Sciences office is located, the Ngunnawal and Ngambri people, and the traditional owners of all the lands on which the Academy's fellows and our panel members and participants live and work. I wish to extend a particular welcome to any Aboriginal or Torres Strait Islanders people who may be online. We acknowledge the custodianship of country that Aboriginal and Torres Strait Islander people have been practicing for thousands of years. And in that spirit, we come together to have this discussion on ways we can respond to the impacts of climate change on the environment and society. The Australian Academy of Science provides independent, authoritative, and influential science advice to guide leaders and decision makers. One of the ways we have been doing this is by convening roundtables of experts to discuss science issues of national significance. We all know the essential importance of dramatically reducing our emissions, but we also need to remove greenhouse gases from our atmosphere and store them permanently if there is any hope of reaching net zero targets and limit global warming. For the last few years, the IPCC has made clear that all pathways that limit global warming to 1.5 degrees Celsius involve removing hundreds of billions of tons of carbon dioxide from our atmosphere over this century. In 2021, the IPCC stated that affordable, environmentally, and socially acceptable carbon dioxide removal options at scale well before 2050 are an important element of pathways consistent with 1.5 degrees Celsius. Humanity cannot afford to underestimate the urgency and magnitude of this task. Australia is highly vulnerable to climate change. It is in Australia's interest to limit global warming as much as possible. Coordinating global and domestic science talent and working together with the social sciences and humanities is critical to understand the drivers of climate change and develop solutions to reduce emissions, remove greenhouse gases from the atmosphere, and adapt to impacts on our lives and well-being. In September last year, the Academy brought together a range of experts to discuss novel greenhouse gas removal technologies and explore the science capability, research, collaboration, and investment needed to support breakthroughs in greenhouse gas removal. I would like to thank all the experts who gave their time and knowledge to discuss this important issue. Developing a range of affordable and environmentally and socially acceptable greenhouse gas removal approaches will better place Australia and the world to respond to climate change and meet the Paris Agreement's goal to limit global warming to 1.5 degrees Celsius. Policy frameworks for greenhouse gas removal are in their early stages, both globally and in Australia. But with investment, cooperation, and regulatory reform, we can develop diverse solutions and explore innovative opportunities to make a real impact. The roundtable was an opportunity to contribute to the emerging conversation in Australia in the context of our renewed national climate policy priorities. The report on the outcomes of the roundtable is now available online. We'll share a link in the chat. I'm pleased to host this panel discussion with 4 of the experts who joined the roundtable. We'll begin with short presentations from each of them to set the scene, followed by a discussion and audience Q&A. You can submit your questions using the Q&A function, which you should find along the bottom of your Zoom window. So now let me introduce Professor Mark Howden and our first speaker. Mark is the director of the Institute for Climate, Energy and Disaster Solutions at the Australian National University. He's also an honorary professor at Melbourne University, a vice chair of Intergovernmental Panel on Climate Change, IPCC, and is a chair of the ACT Climate Change Council. Mark has worked on climate variability, climate change, innovation and adoption issues for over 30 years and has been a major contributor to the IPCC since 1991, sharing the 2007 Nobel Peace Prize with other IPCC participants and Al Gore. And over to you, Mark.
Thank you very much, Jagadish, and welcome everyone. So I'm just going to give a very, very quick rundown on the fundamental rationale for why we need to think about greenhouse gas removal. And when we look at that, it's quite straightforward in many ways, is that what we have at the moment is greenhouse gas emissions are at record levels. So last year was the highest levels of carbon dioxide emissions on record. We're producing something like 42 billion tons of carbon dioxide globally from both fossil fuel and land-based systems. And then there was another 10 billion tons roughly from other greenhouse gases, in carbon dioxide equivalent. So net, we're producing something like 52 billion tonnes of greenhouse gases a year. And that is resulting in record concentrations of greenhouse gases in the atmosphere. So last year, the carbon dioxide concentration was up to 421 parts per million, which is 50% higher than pre-industrial levels. If we look at methane, it's about triple pre-industrial levels as a result of accumulation of those greenhouse gases in the atmosphere from human activity. This has been generating significant climate change, such as increased global temperature, and those changes are unequivocal in terms of their human fingerprint, according to the IPCC. What we're seeing is impacts from those climate changes are being increasingly documented right across the globe, and those impacts are happening faster and more severe than previous assessments would have indicated. And importantly, our adaptation responses are not keeping pace with the rates of climate change. And so consequently, the rationale for reducing our net greenhouse gas emissions seems to be incredibly strong. And yet that's not what we're observing. We're still actually increasing those greenhouse gas emissions. And as Jagadish said, if we're to actually go on emission trajectories which are consistent with the Paris Agreement and the temperature goals written into that Paris Agreement, this not only requires us to significantly reduce our greenhouse emissions right across different sectors, not just from the electricity sector, but also removal of greenhouse gases from the atmosphere. We can only get to 1.5 and 2 degrees and stay there if we have greenhouse gas removal, carbon dioxide removal from the atmosphere. The science is very clear on this. And this greenhouse gas removal is actually the focus of this report. And the report outlines the broad range of greenhouse gas removal options, and assesses the state of the science around those and the state of the policy around those. And thinking back on what I've just said before, the scale of this is really important. We're dealing with billions of tonnes of greenhouse gas emissions per year. So we need to think about options which can be scaled up very rapidly, which are cost effective, which have social license to operate, and which generate economic and other opportunities across Australia. And the other speakers are going to cover this. Back to you, Jagadish.
Thank you, Mark, for those insightful comments. And so now let's go to our next speakers, Dr. Andrew Lenton and Professor Diana D'Alessandro. So, Dr. Andrew Lenton is the Director of Carbon Lock, CSIRO's permanent carbon locking future science platform. His research interests focus on carbon dioxide removal and its role in reaching net zero and transitioning to a net negative world. Dr. Lenton is engaged in national and international carbon dioxide removal research efforts, co-leading the recent Climate Change Authority report on Australia's carbon sequestration potential. Diana is a chemist and a professor at the University of Sydney. She is director of the Faculty of Engineering's Net Zero Initiative, which aims to help government, industry, and communities swiftly manufacture, deploy, and adopt cost-effective, low-emissions technologies at scale. Diana's research team at the University of Sydney is recognized for its expertise in both fundamental and applied aspects of metal organic framework materials. And now I will hand over the podium to Andrew and Diana for their presentation.
Excellent. Thank you very much, Jagadish. Fantastic introduction. So before we start, I'd like to acknowledge, I'm coming to you from La Truita, Tasmania. I'd like to acknowledge the lands of the Muinina people on which I'm on. So thanks very much. I'm going to talk about CDR technologies in Australia and their challenges. It's also worth acknowledging early on that we often use CDR and NET's negative emission technology interchangeably here. So I'll be talking to CDR technologies. So as Jagadish very nicely put, and also Mark as well, we've got a huge challenge here of carbon dioxide removal. We know we're going to need this. We recognise net zero means decarbonisation and negative emissions. So at the moment, globally, it's estimated we're about 2 gigatons of carbon dioxide removal globally. By the middle of the century, it's estimated we need to be at 10 gigatons per year. And by 2100 to go net negative, which is part of where we're going in the Paris Agreement, we're going to need 20 gigatons of carbon dioxide removal per year. So that's a huge task given where we are at the moment. So in that talk, I thought I'd start to talk a little bit about what we could put, what makes up that current 2 gigatons and how we're going to take it up to that 20 gigaton level, and how can Australia play a role in that. So nature-based solutions is one of our current technologies. That really takes advantage of natural biological systems to take up and store carbon dioxide. And of all the carbon dioxide removal that's taken out at the moment, 99.9% of it is around nature-based solutions. We did a recent report with the Climate Change Authority looking at this, and in Australia, there's a huge potential in Australia to accelerate this and move this forward. But there's also challenges because there's competition for finite resources and use. And often a lot of proposed different nature-based solutions such as soil carbon, afforestation, reforestation, others often are wanting to use the same piece of land for different purposes. So there's a real challenge here about how are we going to start to realise and move some of this away from a theoretical potential to a realisable potential. Nature-based solutions have also been really successful because there's been market mechanisms set up around those. We have the ERF in Australia, and also natural capital accounting, valuing the environmental co-benefits that these different techniques bring, means there's been a fairly large adoption of this internationally. Hence, most of what we have is around in the nature-based space. But it's important to note that these carbon sinks, they're finite. They do saturate. You can't infinitely continue to have more and more nature-based solutions. In other words, we have limited land, as I said, we have limited areas for blue carbon, for other things. And so consequently, we actually are going to hit some limits in this space. So what I think the way to think about this is that nature-based solutions are already playing an important role in carbon dioxide removal, and they provide very important amount of environmental co-benefits. And these are critical, but a lot of these nature-based solutions don't offer permanent carbon removal. They're relatively slow, and they also face significant challenges around scalability, verifiability, and vulnerability. Think of bushfire, think of rain heat waves. There's a challenge here. So putting that together, as I said, around the 2 gigatons at the moment, it's really made up of nature-based solutions. This will continue to increase over time, but it can't infinitely grow over time, partly because the sinks are going to saturate, but also some of the stocks we have will turn over again and need to be, we'll need to develop another, we'll need again to be reinvested in or restarted again, so that we'll actually continue to have this nature-based solution. So what I'm trying to say there is it's not going to go up straight up. It can't. There are simple constraints in nature-based solutions to as much as we can get out of the system, and that's a real challenge. So now, so really where we're going at the moment, I think where this report really is important here, it's around exploring what are these novel or engineered CO2 removals that we need to take us beyond that sort of 2, 3, 4 gigatons of nature-based solutions towards that 20 plus gigatons of CO2 removal we'll need by the end of the century. This is also often, so we call them engineered and novel. There's a recent report out using the term novel. I think what we're really trying to say here is to say these are not traditional nature-based solutions. So these solutions include both engineered approaches to take CO2 out of the atmosphere and to store it, and also hybrid approaches. And by hybrid, I mean, for example, using biology to capture CO2, combine that with permanent storage. So currently, we're doing our maths right, 0.1% of all of our carbon dioxide removal internationally is, or about 2 megatons is where we are. So in fact, we're woefully underdone in this space. And what we'll need to do from the previous plot and from everything the IPCC is saying is that we'll need to move from megatons to gigatons really, really fast. There's a Swiss Re came out recently with a statement that said to get carbon dioxide removal to the level that we need it to get to, we'll need to develop an industries that'll be as large as the current oil and gas industries. So a huge acceleration. And my comment here would be, we need to approach this, I think, through a bunch of guiding principles. And I think those guiding principles in terms of where we invest and what we go after is we need to be looking at solutions that will be fast, scalable, permanent, and cost effective. And of course, safe goes without saying, but I think that's, so when we see we need a lot of solutions, we absolutely do, but we really need to focus on those that have the potential to deliver these kind of principles. Australia's opportunity, well, we have a huge opportunity in Australia. We have a vast land area, great mineral wealth, a lot of experience in mining and renewables, huge opportunities with renewables. We have the third largest marine estate of any countries. We're very aware that there's already a lot of use going in a lot of places, but nonetheless, we have a huge opportunity in Australia if we can get clever about how we use our natural resources. What we ultimately need are solutions that are suited for our unique environment and our natural assets and are in our natural interest. And I think the comment, even a back of the envelope calculations to date, say that we have the potential for many hundreds of years of global emissions to be stored in Australia. So what's it going to take to realise that potential, to also get CDR, but also for Australia to play a role in that space? Well, it's going to need breakthroughs everywhere. Really, that's the simple answer. Harder to do, and Deanna will touch on this a little bit more. But so what I think we need enabling technologies that take carbon dioxide out of the atmosphere. We also need enabling technologies that can store carbon permanently. And when I say permanent, I'm talking hundreds to thousands to hundreds of thousands of years is where we want to be in this space. And we want to be combining those enabling technologies together to permanently lock the carbon and deliver these negative emissions or this carbon dioxide removal we need. In terms of, and I thought I'd go through just a couple of quick examples here that are touched on in the report that I think is, where I think Australia has huge opportunities. One of them is in direct carbon removal. There are a number of approaches, biology, chemistry, and others. We can use biology to do this. There's great work going in Australia in this space. We can also scrub CO2 out of the atmosphere. Deanna touched on the work she's doing. We have others in CSIRO doing this work, many other universities. And there's also a lot of ideas around how do we start to take the CO2 out of the seawater? And we saw that in the video at the beginning. So all of those have a potential to actually be scalable and to be able to remove a great amount of CO2 out of the atmosphere. It's not storing it, it's able to remove it. But there are still challenges. To realize that potential, we've got to increase our capacity. We need to be reducing energy and the costs. We need to look into modular approaches, and we need to look at clever ways to capture it. We've got amino acids, we've got metal organic frameworks, we've got membranes. There's a lot of work still to do to be able to take this up. Another example that I thought was really exciting for Australia is around the permanent carbon storage enabling technology, which is really around mineral carbonation. Australia has a huge amount of resources in terms of mafic and ultramafic rocks that can react with carbon dioxide. So we know in terms of using existing mine waste and other material, we know the carbon dioxide can react directly with the rock. You can see in the lower left-hand side of this, you can see at the Mount Keith nickel mine in Western Australia, you can see that slab of new rock forming just reacting with the overlying air to create new rock. That's the ex situ piece. There's also the in situ piece, which is around moving beyond carbon capture and storage, getting away from supercritical liquids and starting to move towards putting CO2 down into mafic and ultramafic rocks to react the CO2 and lock it away there. And this is done in Iceland at the moment. But there's a huge opportunity for us to do that within the Australian continental Australia, but also potentially offshore as well. Finally, I think the third piece of that is about putting together the enabling technologies to get to solutions. And some of the examples that people are talking about here, and I think we need to be exploring in Australia, is can we both lock CO2 in rock, but can we also produce an alkaline material that we could add to the ocean that offsets ocean acidification, also sucks up more carbon dioxide, but also produces hydrogen at the same time? It's this kind of clever putting it together that we need to think about. Another example here is, can we start to think about in the upper right-hand panel, so for example, direct air capture on rail cars? to and from mines? Could we, as we push material back and forth, can we capture the CO2 and then dispose of it at a mine site where we have the appropriate material? And of course, the circular economy has a huge role to play in this as well. So that I'll leave that there. I just thought I'd say that next week we're also launching, we have my permanent carbon locking future science platform will be launched next week. And I would encourage you, if you're interested to know a bit more about what CSIRO is doing in that space, please go to our website and please register for that webinar. We'll be going into a little more detail about many of these topics. Thanks very much.
Thanks, Andrew. And so now I'll ask Deanna to make her presentation.
Thank you very much, Jagadish. So first and foremost, I want to acknowledge that I'm on Gadigal land here today at the University of Sydney. And I also want to disclose that I work on a negative emissions technology called direct air capture with the company Southern Green Gas. So as Mark and Andrew and Jagadish have mentioned, there are enormous challenges and opportunities here with greenhouse gas removals. And the reality for us is there is going to be no silver bullet. And in fact, we're going to need a portfolio of solutions. But the opportunities here really do need to be emphasised, and that is that not only are greenhouse gas removals going to be essential for us to reach net zero and stabilise our climate, but actually the scaling of these industries, as Andrew mentioned, will actually provide enormous opportunities here. A new regional manufacturing sector for Australia, of course, aligning with multiple state and federal level strategies, including Australia's long-term emissions reduction plan and our Advanced Manufacturing Fund and our Critical Technologies Fund. So really what we're talking about here is a new billion-dollar export industry in carbon removals for Australia. And it's not just the carbon removals side. There are also opportunities here, if you like, to create circular economy with carbon, really, if you like, fundamentally rethink carbon. So there is a transition that we urgently need to make in Australia, and this means that there is the opportunity here to create jobs, particularly in regional and rural Australia. And with that comes the enormous responsibility we have to work with those local communities and consider very carefully what the co-benefits for those communities might be. So the first question really then is, how do we actually integrate greenhouse gas removals in order to really accelerate responsible deployment? And I think first and foremost, really what we feel is that there needs to be a national level strategic coordination and connection. We know that there's nothing wrong with healthy, if you like, competition, but more than ever, this is a problem that we need to deal with through collaboration and partnership. And so here we really need to consider a multidisciplinary assessment of the short, mid and long-term options. And Andrew's already alluded to the fact that, of course, there are shorter term options nearer, closer to market, like nature-based solutions, but we need to consider the permanence here. And so we do need to be considering how we are going to actually, in the mid to long term, permanently lock away carbon dioxide. So this means, of course, supporting all of this through modelling where possible. And the question then is, well, are our current research governance structures actually fit for purpose? And the answer we think is, well, in some ways, but actually this is a time that we really need to organise scientific R&D. We need to consider carefully our translation and, importantly, at the national level, figure out how we're going to actually engage with our communities to deploy these technologies responsibly. This, of course, means raising the visibility for the solutions and the technologies to help attract investment. And it also means really understanding very well what the knowledge gaps are, as Andrew alluded to. So the need for interdisciplinary research on co-benefits, trade-offs, governance, and of course, social acceptance, remembering that it's critical to ensure that our First Nations people are represented in the decision-making. So the other part to this, and we've just had we're in the second week of the university semester here, is investing in people, in the human capital who are going to lead and drive this transition. So investing in the education for earlier career professionals, but also mid-career professionals, because our industry partners are telling us that there are skills gaps and knowledge gaps, and we need to help to pivot the workforce and help to explain what these opportunities in decarbonisation are. So then the second question is really, how do we engage in order to accelerate responsible deployment? And the first thing is really around engaging early with the public to help them understand these technologies. There is huge international momentum, as Mark and Jagadish and Andrew alluded to. So we can really leverage those strong partnerships we have, particularly, for example, with our US partners who are well along their journey, having just established their Emissions Reduction Act. We need to engage early with policymakers, and that's really what this discussion is about opening that discussion. We're very fortunate in Australia to have a stable market, political and legal system. So this gives us a great basis for actually being able to implement these solutions. And we think also we need to learn from past mistakes. Successes are important to celebrate, but actually there are places where we can really learn in Australia from where integration of technologies into communities has not gone so well. And we need to understand what didn't go so well and how we can actually accelerate this transition in a responsible way. And perhaps the final thing here is really that our universities, industry, government, communities, private investors, the financial sector, voluntary markets, philanthropists, and not-for-profit sector, just to name a few, need to more than ever come together to establish collective voice. Jagadish, back to you.
Thank you, Diana, and thank you, Andrew, for both of your insightful comments. And now I would like to remind the audience to submit your questions for our panelists via the Q&A button at the bottom of your Zoom window. Our final speaker is Professor Jan McDonald. Professor John McDonald is a New Start Professor of Environmental and Climate Law at the University of Tasmania and Deputy Director of the Australian Forum for Climate Intervention Governance. Her research focuses on the legal and regulatory settings needed to incentivize and govern the risks of novel climate interventions, including greenhouse gas removal and solar radiation management. Over to you, Jan.
Thank you very much, Jagadish, and thanks everybody for joining us today. I'm joining you from Lutruwita, Tasmania, as was Andrew. I'm going to provide a very brief framing presentation today, just to give you a sense of the policy and regulatory challenge that we have ahead of us. Diana talked about the fact that we need to focus on responsible research, development and deployment. And I suppose what I'd like to leave you with is the message that we need to make sure that our governance settings, our policy and regulatory settings focus on that idea of responsible RD&D. So I've put there that our governance priorities are really twofold. On the one hand, we want to facilitate and incentivize both the important R&D to work out what the best combination of technologies might be over different timescales, because there are some things that are ready for deployment right now, but others that are going to require a longer lead-in and upscaling. So we need a really effective governance framework that's going to incentivize all three elements of research, development, and upscaling and deployment. But at the same time, as the others have already foreshadowed, many of these technologies, once they're deployed at scale, will have different sets of environmental, social impacts, potentially human health impacts that will involve really difficult trade-offs. And so the other key priority for our governance of these technologies is going to be to find ways of best managing those trade-offs and minimizing the undesirable impacts. And we have essentially international law that will direct Australia's policy and governance position on these issues, as well as already having quite a sophisticated domestic regime. In terms of the incentivization piece, the Paris Agreement is obviously our starting point for that. At the moment, the Paris Agreement commitments in relation to each country's nationally determined contributions don't require countries to draw any clear distinction between emissions reductions through offsets, and then active negative emissions. And a key area of possible reform in that space would be to expect countries to have at least some part of their nationally determined contribution that spoke specifically to the positive contribution that they could make by actively drawing down and not just using it as a way of avoiding their mitigation commitments. At the international level, in terms of reducing adverse impacts, we have a galaxy of international frameworks. We obviously have Law of the Sea Convention, Law of the Sea treaties, both UNCLOS, but also the more specific provisions of the London Protocol that at the moment are not necessarily fit for purpose in respect of some of the technologies that Andrew talked about in relation to ocean alkalinisation and so on. We have the Convention on Biodiversity that provides that overarching obligation to Australia to make sure that with the upscaling of carbon forests, for example, we aren't putting in place monocultures that compromise biodiversity. And I'd also want to just highlight that against all of that is against our treaty framework is the backdrop of customary international law. Moving to the Australian domestic framework, we do have the foundations for an effective framework for incentivising the deployment of these kinds of technologies at scale, but there is going to be more work needed in this space. We need to make sure that the Climate Change Act and the statements that come from the Climate Change Act speak not only to emissions reductions targets, but also to drawdown targets as well. Again, mirroring what I'd like to see at the international level. There's also a piece of work to be done in relation to the enhancement of the safeguards mechanism to see whether we can actually move that towards not just reducing emissions. Many of you would be familiar with the recent report of the Chubb review of the Australian Carbon Credits Unit Scheme, and there are important work. There's important recommendations in that report in relation to enhancing the integrity, expanding the number of technologies, reducing the complexity of the methodologies and compliance with that scheme, and providing better mechanisms for recognising First Nations rights as well, and recognising and ensuring free, prior and informed consent. Finally, in that bottom quadrant there, you can see that we, again, have a very significant existing framework for safeguarding against adverse environmental, social and other impacts. What we don't yet have, and I think that Deanna foreshadowed this as well, is a very good approach to coordination of the very significant program of research, development and deployment that will be needed. There are opportunities on the horizon for doing a better job of this. At the Commonwealth level, the Nature Positive Plan talks about the government's intention to develop bioregional plans that could do a really great job of identifying where future greenhouse gas removal activities are best located for whatever technical or social or environmental reasons. But some of these technologies will have different kinds of impacts. And so we will also need to look at state level, for example, health and workplace health and safety legislation to make sure that we are addressing some of the, or avoiding some of the unintended side effects. This is a really significant task, and that the fact that we're going to need a portfolio of responses makes this regulatory task in managing and safeguarding against adverse impacts much more complex. There won't be this single law reform project simply to address some of these issues. It will happen iteratively. And I think that what we may end up needing is special sort of sandpit type allowances for particular R&D projects to happen in the first instance so that we can explore and understand their potential both for benefits but also for addressing risks as well. But this is something that will require coordinated policy oversight. And I suggest that given the risks of transboundary impacts, that really is a role for Commonwealth government to take leadership on, both at the research and development stage, in anticipation of having a framework that is ready to go when we're ready for the massive upscaling that we're going to need. Back to you, Jagadish.
Thank you, Jan, for raising some important issues of concern in terms of having the right legal frameworks in order for us to be able to pursue these technologies. And our panelists have provided some excellent context setting for our discussions. And particularly, our panelists have identified the scale at which the carbon dioxide removal need to be done at 52 billion tons, which is a major challenge. So now let me ask the first question. So now I think also please, write down your questions in the Q&A part of this Zoom link below, so that we'll be able to get back to you in terms of the questions you may have. But let me start with a question about to the panelists. Where are the knowledge gaps and areas of understanding that need to develop for the greenhouse gas removal? So I'm happy for any of you to take that one.
So I'm happy to have a go.
Please go ahead, Andrew.
So I think the knowledge gaps are around, I think all of this panel really covers many of those knowledge gaps. It's about, it's societal, it's about social acceptance, it's about economics and, the costing of this as well. It's about the, regulatory environment, and it's about the science and the technology advancement. So it's really around, the intersection. I think we would be remiss. And in fact, history is littered in technologies that didn't end up going forward because that social acceptance was not achievable in some ways. So I think this integrated piece, and there are others that can speak much more eloquently to this around the call, but I think it's really that intersection of economics, social, technology, and others that is the information we're going to need to take this forward as a nation, and also have an informed view as a nation on this important topic. Back to you, Jagadish.
Okay. Thanks, Andrew. And so maybe let me go to you and Deanna. Both of you have given a great, excellent overview of some of the ways we can remove carbon dioxide from the atmosphere. Are there risks associated with these technologies, and what things do you need to consider? Because there's always a challenge when you're developing new technologies. There's always pros and cons, and then what are the issues which we need to keep in mind while really developing and deploying these technologies at scale?
Absolutely. Well, I think Andrew really expressed that in a nutshell very nicely, and that is that this is a multifaceted challenge that we're facing. And in fact, there's not one piece of the jigsaw puzzle here. It's that there's many pieces. It's more than 100-piece jigsaw puzzle here. And in fact, Mark, Andrew, and Jan have alluded to some of the pieces of that jigsaw puzzle that we need to put together. So with regard to the scaling, I think one concern that perhaps we haven't touched so much on is the aspect of how biodiversity might be impacted. So Andrew alluded to, for example, nature-based solutions. And in fact, in Sydney today, the Ocean Leaders Summit is being held, which is really opening that conversation around the potential of our oceans to actually address carbon removals. So that conversation is it's the very, very early stages. And so this aspect of not just nature-based solutions, but also obviously technological solutions, and how, given that they will be using and falling upon Australian soils and our Indigenous lands, how will that how can that be done in a way that's safe, such that it doesn't impact biodiversity? And I think the answer here is really, it's the coming together. It's that we cannot solve this in our silos alone. And more than ever, we as a community have, we recognise that. And actually at an early stage, we want to be there at the table together, recognising it's a multidisciplinary problem, and recognising that to scale this without impacting biodiversity, and to ensure social justice in this transition that we're making, that actually that's something we need to do together. And we're here to do that.
Okay, thank you, Deanna. And so for that insightful view about that particular topic. And Mark, do you want to say anything on top of that?
Look, yeah, just briefly, Jagadish, just to sort of expand on those points that Deanna and also Andrew have made, is that I think another one of the risks that we need to be very aware of here is that associated with moral hazard and some sectors of society seeing the potential for these sorts of technologies to essentially substitute for action by themselves to reduce greenhouse gas emissions. And so I think we need to be really clear that there's the first priority should actually be reducing the core greenhouse gas emissions, particularly fossil fuel-based ones, before we really ramp up what is actually inevitably going to be a fairly expensive and challenging agenda to actually get to the gigaton scale of greenhouse gas emission removal. So we need to do that. And one of the other risks associated with simply that scaling up is alternative expenditures. So if we are to develop such a huge sort of industry and infrastructure there, inevitably the questions will come up about, well, we could spend that money in other ways, and what's the most appropriate way of expenditure for that? And then that could generate a whole series of perhaps problematic discussions which don't lead to places which we generate activity going forward. But on that topic, it's important to recognise that when we emit a ton of carbon, that has net negative costs across the globe. It's what's called the social cost of carbon. And there's been a few studies over the last few years looking at that. And essentially this takes the negatives associated with greenhouse gas emissions through climate change and health and other issues, and the positives in some places, and then puts them together to get that net social cost of carbon. Two studies, one of which a few years ago came up with a median cost of $417 US. So think about 550 Australian dollars a tonne. A more recent study was about $200 US dollars, so I think $300 a tonne. That's the cost of emitting a tonne of carbon dioxide as best we can estimate. And so anything less than that in terms of what we can do in either emission reductions or greenhouse gas emission removal, in a sense, makes economically rational sense to do. So we actually have a lot of room to move here, but at the moment, our sort of economic framing and the way we cost things doesn't allow us to do those bigger scale sort of assessments that lead us down to most effective decision making.
Thanks, Mark. And do you see this as a core benefits in terms of the improvement in the health of the people if the global warming or the temperature of the planet is reduced? And then what are other core benefits we can really expect by deploying these technologies?
I'll just chip in briefly. I think the challenge here is that there's so many different technologies across this spectrum that there's consequently many different co-benefits that could arise. So Andrew has already mentioned a couple of these, so for example, with the electrochemistry in the oceans, where sort of potentially carbon dioxide absorption, but also alkalinization of the oceans, because our oceans are getting more acid at the moment. And so there's a co-benefit there which could propagate into things like less risk for our coral reefs and increased productivity of our coral reefs and things like that. So each of these will have its own series of potential trade-offs and potential co-benefits. And the challenge I think that Jan was raising for us, and also Deanna, was how can we actually construct a series of institutional arrangements which reduce your trade-offs and enhance the co-benefits, and be confident that we can actually deliver on those.
Okay, thanks, Mark. And so in terms of what is the role of responsible innovation and community engagement in the development and implementation of greenhouse gas removal projects? And some of you have touched on that one. And so sometimes scientists or the technologists start engaging with the community after developing the technology, but in this case particularly, it may be more important we start engaging with the community at the early stages so that we can take into consideration of the communities, the concerns and thereby we're able to ensure that we get the social license to be able to operate that. Would you like to comment on that?
I'll kick off the conversation on that one.
Please
It's
go ahead, Jen.
a tricky issue. I'd start by making the observation that there is no single community, and different technologies will engage with different communities. And so even at the research and early field testing stage, some of these projects and technologies will need to engage with the landowners, the native title holders or traditional owners of the actual land and sea country that the activity is going to be trialled on. The community then might well be other landowners who may stand to benefit from the larger scale deployment because there are effective incentives put in place. I think where we need to engage the broader Australian public is in the conversation about what role negative emissions plays in Australia's overall contribution to climate change mitigation, and getting the public on board with the idea that it's not just about mitigation of existing and new emissions, but the actual sort of hard task of drawdown. And getting people on board with that, I actually think is quite an easy sell conceptually, but it will probably come at a cost. There are also opportunities for there to be savings and benefits to the community that we've talked about. If we do the more biological nature-based sequestration well, there are really terrific opportunities for the community. So my key thing here is to emphasize that early engagement is essential, but the communities that one might engage with early on may be different from the longer term conversation that needs to happen and over a longer period of time and evolve. Sorry, the opportunities for Australia. Well, the opportunity is that we actually do it well rather than doing it poorly, if I can put it in those terms. We can't afford for us to have uncoordinated policy in this space. We need to make sure that as we are doing the R&D, we have an eye towards how things will be deployed in the future, and make sure that the regulatory settings that we have in place to incentivize and safeguard enable R&D to happen and to happen responsibly, but also think forward towards the future. We do have some examples of how that's occurred in the past in relation to the early regulation of nanotechnology development, not so much in Australia, but internationally. But I suppose my response would be that we have opportunities that are obvious because we can't afford to have a fragmented and uncoordinated approach to this. And I think that the others also spoke to the importance of that.
Okay, thank you, Jen, and for those insightful comments and the importance of working together and making sure that the right kind of policy frameworks are in place. And then Mark, please.
Thanks, Jagadish. And just to sort of build on what Jan has talked about, particularly in relation to sort of domestic concerns and opportunities and the need to work together, I think we can expand that out to the global and see, because the same sorts of questions will be currently being asked, in the US and in the EU and many other places. And one of the opportunities I think for Australia is to be a first mover in relation to this and establish something like a global entity, a global institute, which actually coordinates research globally. And by doing that, we could actually then leverage very significantly relatively small amounts of contribution into that, into a much bigger pool of funds. And I think apart from just simply the potential for sort of leverage and leadership here, I think there's a lot of potential reputational benefits that can come, as well as the opportunities for very significant returns in an academic sense, and in terms of the economics of being able to develop technologies here and then have green export opportunities elsewhere. So I'd be thinking global. I'd be thinking about how the Australian government can, be a first mover and actually start to coalesce activities around this at that global scale.
No, please go ahead, and thanks, Mark, and Andrew. Please go ahead.
Look, thanks so much. I just wanted to add a couple of quick things to that. I think one of them is really around the industry engagement. I think academia and industry have a huge opportunity here to work together, and how we do that is up for discussion. And I think there's a new paradigm here that we can start to explore. So I think, while we look towards developing new technologies, let's look also for new modalities. In that, as well as philanthropy. We haven't traditionally perhaps talked as much about philanthropy in Australia, but we know that there's a lot of philanthropy, there's a lot of interest in investing in the space. How do we, as an academic community, industry, and start to engage with this philanthropy and sort of start to think about it? And I think that becomes a really interesting regulatory piece as well, because traditionally our agencies have a way in which we work, but often it's all, the gloves are off with some of these philanthropic ideas, the need to accelerate, the need to move forward. So I think there's a part of everything that's been discussed. We need to think about also how we're going to work in the future. Who and how we're going to work together is a key question. Thank you.
Okay, thanks, Andrew. And so maybe I think before I open the floor for questions from the audience, and let me finish off with the last question. And I think both of you have already covered some aspects of it. So what are the key things we need to do to support development of these technologies? I think Mark and then Andrew, you mentioned those ones, and any of you want to make any further comments and before we open the floor for questions from the audience?
Well, I'll start off with one sort of perspective on this, is that if industry is going to invest in these sorts of, the R&D and then the implementation of this, they need to be confident that they're going to get credit for whatever sequestration they undertake, the greenhouse gas removal that they do. And that in turn requires an understood and agreed inventory approach for greenhouse gas emissions, preferably as part of the IPCC structures, so that we, for any one of these, possible technologies, there's a well worked through way in which that you can actually have, account for those removals from, greenhouse gas removals from the atmosphere and the security of those. And so that's a fundamental requirement, I think, which is a transparency and accountability framework, which operates at both domestic and global scales.
Okay, thanks, Mark. And Deanna, please.
Yeah, I mean, that I totally concur with Mark's thoughts there. And I just thought I'd perhaps add there that this is not just a problem or a challenge for the applied scientist or the engineer. So a lot of the sort of close or near to market, if you like, solutions for carbon drawdown are sort of based upon decades long knowledge, if you like, but there is serious potential here for new fundamental scientific discovery. So the deep integration of if you like, an industry problem coupled together with fundamental science cannot be underestimated. And that's an extremely complex interaction. And I guess what I'm getting at here is that this is not just something that can be solved by funding for the applied problem, that actually this is together both the fundamental science and the application that we have to solve here. And so actually there's a real opportunity for Australia also to sort of lead with regard to innovation in fundamental science as well.
Thanks, Deanna. And any further comments before we go to the floor? So if there are no further comments, and now I think we'll go to the floor and then ask the audience questions, and please submit your questions to the Q&A at the bottom of your Zoom window. Lauren, do you have any questions?
Yes, we do. Thanks, Jagadish. I've got one here from Andrew Pedley, who asks, does the panel, especially Professor McDonald, have an opinion on the risk presented by the paradigm of regulated innovation versus letting innovation loose and regulation following as things break or fail? Is there a precedent of essentially state-sponsored innovation?
I was really hoping this question wouldn't end, we wouldn't have time for this one. I'm not sure that I agree with the assumptions that are embedded in the question, that having some form of regulation to safeguard against the risks of experimentation constitutes state-sponsored innovation or regulated innovation. To me, as soon as we take experiments outdoors into any kind of large scale, we are obliged to make sure that what we're doing has enough benefits that it offsets the potential environmental and other impacts of undertaking even the experiment. So in that respect, I'm not at all troubled by what you describe as the risks of a paradigm of regulated innovation. In fact, I'm more troubled by a paradigm of unregulated innovation. And that is probably one of the things that is most concerning in the field of solar radiation management, for example. And any of you who follow that space would know that there's a real concern there about rogue operators and the risks associated with that. But we have plenty of examples of novel technologies that have, where it has been recognized at the very earliest stages that you need to regulate at the R&D stage, because by the time it's ready for deployment, regulation might be too late. I would put it out there that what we're seeing at the moment with AI and ChatGPT might well be an example of where we've let the genie out of the bottle and it's too late to do appropriate regulation of how that technology might end up being used. So I suppose I was reluctant to answer this one because I disagreed with the premise of it being state-sponsored innovation just because we regulated it. Others might have a different view.
Thank you, Jan. And yeah, any of you want to make any further comments? Yep, good. Okay, maybe Lauren will go to the next question, please.
Yeah, sure. Sorry for picking the tricky question first, Jan. We've got one here from Stuart, directed at Andrew, but open to the panel. We've got less than 30 years to develop an international industry of the same scale as today's oil and gas industry. That seems quite ambitious. Is that something that our current economic government systems can do, or do we need to be looking to rapid innovation in our political system as well?
And Andrew, unmute yourself. Looks like.
Sorry, forgive me. Please forgive me.
Okay, please.
Thanks very much for the question. I apologise. I would never, as a CSIRO employee, comment on government policy and where we need to go, of course. But I think it is. I think you've nailed the heart of the problem, the challenge, and how do we do this? And I think ultimately my question would be perhaps more along what Mark said earlier. How do we globally coordinate everything we need to do so we don't invest in technologies that we know simply are not going to get us to where we need to go? So we need to be willing to also share our scientific breakthroughs, but also our failures. We need to be willing to celebrate success, because that means we're not investing in this area of science, and we need to be willing to get beyond commercial incompetence in those kind of discussions. So I would say open, transparent science is critical. I would add further that part of this in the Australian context is also around raising the IQ about negative emissions. So this is a really, really, really important discussion to start to have. How do we start to build this literacy? So in some senses, it becomes a natural. So this becomes something that we have a position on, and we know the importance of, and we also know what are the potential benefits, co-benefits, and deleterious effects of what we're embarking upon.
Thanks, Andrew. And Mark, you want to make a brief comment on that?
Yeah, just to follow on from that, and because I work in the university, I can actually comment on the policy and politics. But look, I absolutely think that we do need to have a more informed discussion, and that's why I think this report's really important, as are some of the other reports which have been mentioned today. And but this is only the start of a journey, and this journey will be a multi-decadal journey. And I think that's the big challenge in terms of changing our political system, is how do we convert a political system which tends to look, at most to 3 years or 4 years out, to something that looks, 10, 20, 50 years out, or maybe longer. And that's the biggest, reform, I think, which is needed in how we think about politics here in Australia. Some other countries do it, the multi-decadal stuff much better than we do, and I think we do need to be starting to, gear up to that, and for the public to expect that from politicians. There's other entities across our society that can look after the next week, next month, next year stuff. We should actually have governments that look after the next decade and next century stuff.
Thanks, Mark. And maybe we'll go to the next question. And Lauren, please.
I've got a question from Rachel, who says, there seems to be a gap between emerging innovations that are not commercialised and how the Innovation Fund incentives are constructed, especially for international collaborations. Why aren't there more or accessible incentives for overseas-based companies to work with and develop Australian innovations? If there are, how do we access them? That might be a bit of a tricky one for our panelists to answer. I guess if there are researchers who are working on these kinds of technologies doing this research, how can they be looking for collaboration and being proactive in this space?
Well, I will have a little bit of a go at that at the beginning, if we don't mind. Some dimensions of that. Look, I think there are some international initiatives already that things like Mission Innovation, the CDR mission, and other things like that do connect internationally, and that are starting to really build momentum in this space. But I think I won't speak to investment, but I think part of the thinking here is, yes, Australian industry, we often talk about the valley of death for innovation in Australia. I think we need to also think about potentially our role in things like, international test beds, potentially for different technology, different approaches. How do we not lose our talent to overseas, as we traditionally do in a lot of areas, but how do we bring people back here and start to have a real focus here in Australia? And I think that's a really difficult question, but I think as we embark upon this, we should be thinking about that. And I would say test beds could be one way to do it, but certainly looking at, I think there's certainly a need to get to a point in which, especially as capital's raised in some of these areas, that there's some at least base level of validation of the claims that are being made in some senses, because it's very hard to get investment areas if you can't push this beyond the lab scale, and if we don't have that kind of environment here. So how do we foster that is a question that I don't know the answer to, but I'm really excited to start to have this discussion with policymakers to start to explore, what are the ideas out there.
Thanks, Andrew. Yeah. Lauren, maybe we'll go to the next question. Yeah.
Yeah, sure. Leading on from that, kind of looking at the international context, can we talk a bit about what is happening in other countries? Sorry, I'll phrase that as a question. What do we know about what's happening, what other nations are doing in this space?
Mark, you are aware of any of the efforts which is happening globally in this area?
Yeah, there's a and I see Andrew's got his hand up too. There's actually a lot happening, particularly in Europe, but also in the US, and we've got examples where companies are already going down this pathway. So Climeworks in Europe, etc. Some significant sort of activities in Canada and the US as well, along lines of carbon dioxide capture, direct air capture. In Europe particularly, it's relatively well organised, not just because it's being driven by the greenhouse gas removal agenda, but it's actually part of the much bigger circular economy agenda that Europe has established, and which is supported by a whole series of policy frameworks and industry activities. Over in Europe, there is actually an entity called CO2 Value Europe, which actually brings together players in the research and policy domain and industry domain across Europe, and so that's actually quite a significant activity in its own right. You know, generating the sort of networks and cross EU capability. There's a small entity in Australia which I'm part of, which is just a little non-profit, again, to sort of raise the level of discussion about carbon dioxide capture and utilisation. And so I think there's, you know, some things there and elements there which are not just about the research, but it's actually about how to translate the research and connect the research. And I think that's sort of part of the sort of more mature ecosystem that we've got over in Europe in relation to this than we have in Australia. So we're starting behind the 8 ball. It doesn't mean we can't catch up and leapfrog, but if we just twiddle our thumbs, we're not going to do that, and a whole stack of opportunities are going to be missed, and a whole stack of risks may accumulate for us. So I think there is a job to learn a bit more about what's going on overseas, to keep our finger on the pulse there. And I would argue that the purpose of that is to actually find out how Australia can effectively play into this space and leverage from this space.
Okay, thanks, Mark. And so, Andrew.
Mark, they're great points. In terms of programs, yes, there's the Earthshot, you know, there's Earthshot, Moonshot, Japan, the US. There's a huge amount of money. You've seen the amount of money go. We've seen the direct air capture money that's available. There's huge resources going into that. Japan is very active in this space. Saudi Arabia, there's a lot of other efforts going in this space. I would say at the moment they're quite nascent, given only 0.1% of what we're doing is in this engineered space. Most of the focus has been on the nature-based. So there's only a small amount of effort building in this, that's starting to build momentum at the moment. There are some, Mission Innovation is one that tries to bring everyone together. There are a number of them that are trying to bring these initiatives together. And so I think one of the really positive things that comes about by not necessarily being one of those first movers early on in this research is the fact that we can really look to those like the Department of Energy and learn what was successful, what didn't work, what would you do again? How can we start to really turbocharge based on that kind of knowledge? And I would say from an Australian perspective, there's not a single researcher I haven't reached out to in Europe, US, UK, Asia, who hasn't been willing to be very forthcoming and really start to talk about, you know, what they're doing, how excited they are, and how could we do more together. So, you know, the willingness is absolutely there. It's just a matter of us, in part, bringing our Australian community together a bit more so that we share what we have here to connect to what's going over there. So we have a bit of a coordinated approach.
Okay, Jan, and I think you have to unmute yourself. Please go ahead.
Yes, I was just going to add something from the governance perspective, and that's to say that there's actually been quite a lot of work done to recommend codes of conduct, principles for responsible innovation in this space. A key priority going forward is going to be in the area of assurance and verification to make sure that we're capturing what we're saying we're capturing, and we're sequestering it over long time scales, and to give people a sense of the kind of investment that's going to be needed there. In the last week, Joe Biden has announced $45 million just to focus on MRV, monitoring, reporting and verification of marine-based carbon dioxide removal technologies. So there are significant things happening both on the technology side, but also on the investment in the future governance of those technologies.
Okay, thank you all. And looks like we got plenty of questions here. So may I ask the panelists to be brief in their answers? And I know that you want to make the key points, and then so that we can cover most of the questions from the audience. And Lauren, let's go to the next question, please.
I've got a question from David Caroli. Andrew, how confident are you that nature-based CDR in Australia can expand significantly, given the current and future impacts of marine and land heat waves, drought and bushfires causing major losses of existing marine seaweed, kelp, forest carbon, soil carbon, etc., let alone any new nature-based carbon storage? How permanent will that new storage be, as it needs to last for more than 1,000 years?
Thanks for the question. Look, I think we've just done a fantastic report. We won't go into it now for the Climate Change Authority, really looking at Australia's sequestration potential. What we recognise at the moment, we've done a lot of work looking at our theoretical potential. We need to understand what that means about realisable potential. So at this stage of the game, we don't know how vulnerable to our stocks be to climate change in the future, what competing resources will there be. That's really ongoing work at the moment. I think in terms of the broader question you're getting at, David, I think it's about the portfolio. And I think we have to be thinking about also the portfolio in terms of, amount and time as well. For example, if we're designing portfolios that have nature-based solutions, they're not going to be permanent. We just know they'll have a finite period of time when they need to be renewed to keep that portfolio full. I think if you were designing a market mechanism, you might try to incentivize permanent removals and try and make those perhaps the premium product, if you will, in some ways. But that's the market and the Clean Energy Regulator and others to speak to in the policy sense. But I think certainly we want to incentivize the permanent removals, but ultimately we're 0.1% of where we are at the moment is in the engineered space. So we certainly don't want to be not using nature-based solutions with the environmental co-benefits they have. We just need those, more of those, and again, an order of magnitude almost more beyond that.
Okay, thanks, Andrew. And maybe we'll go to the next question. Lauren, please.
Yes, here's a question from David Adams. Can we use our farming of plants and animals as an ecosystem service to draw down greenhouse gases? Andrew, or maybe Mark?
Yeah.
I'll pick it up then. So yes, we can, but we also need to be cautious about it. And so there's a lot of, I think, hype about the potential there, which is not supported by the potential, the practice and the risks associated with those. And some of those risks are aligned with what David Carroll just raised, with potential future droughts and fires and things, placing stocks of carbon at risk. So I think one of the perspectives on this is generated by some work out of Melbourne University, which looked at the ecosystem service of increasing soil carbon in agricultural systems versus the atmospheric service part of drawing that down, in other words, sort of carbon credit value. And what they particularly found, this is Rochelle Meyer and Richard Eckard, was that the ecosystem service value in terms of improving soil moisture, holding capacity and infiltration rates and similar things was about 10 times the value of the atmospheric service. And so that if you actually think about that, it means that the rationale for its increasing soil carbon should be there regardless of climate change. Climate change response, through soil carbon sequestration to draw down carbon is really the icing on the cake. It's not the cake itself. And if that analysis is right, then you should be asking why aren't farmers actually stacking away huge amounts of carbon in their soils and vegetation now? And the answer is it's not that easy, and sometimes it's not that financially viable thing to do. So I think we need to be very positive about carbon in our landscapes, in our farms, but really recognise that the key driver for that should be sustainability and profitability reasons, not for climate change amelioration reasons.
Okay, thanks, Mark. Lauren, let's go to the next question, please.
I have a question from Thomas Moore. Recognising the potency of methane and the risks of release from tundra, etc., is there a considered way to remove this greenhouse gas in the future?
Who wants to take that one?
I'll do it a little bit. Someone else might have read up more of the literature. So there have been some experiments to look at stripping out methane in a similar way is that we strip out carbon dioxide through direct air capture. But the trouble with methane is it's measured in parts per billion, and so you're dealing with a very dilute gas, and so it tends to be quite energy intensive to do this. So it's not at the scale, the technology readiness level, I guess, that the direct air capture is. But of course, once you capture methane, you can treat it as a waste product to get rid of, or you can treat it as a resource. And that's a general thing which I think we need to think about in relation to greenhouse gas removal, is that a lot of the framing of how we deal with carbon dioxide and climate change is thinking of it as a problem, as a waste that we have to get rid of. Whereas an alternative way of thinking about this is thinking about carbon dioxide as a resource that we can use to make valuable products or get valuable benefits from, for example, the ocean acidification reversal benefit or the hydrogen generation benefit there. And so I think part of this, the story here is we actually have to have that conversation that where appropriate starts to reframe it, to think about some of these things in a resource and profitability sense than a waste and cost sense.
Okay, thank you, Mark. Okay, Andrew, yeah, brief one, yeah.
To that, and that's to say, part of the motivation behind CDR is also a realization there will be continued emissions from subsectors, agriculture and others. We're not going to get it, some of the non-CO2 gases, we can't really get away from those in the short term or even potentially the longer term. So part of the motivation of needing such a large amount of CDR is also so that we can almost in perpetuity offset that as well. So, what we're talking about in this conversation is net zero, not zero emissions. So that's a really important piece. So that's decarbonisation plus CDR.
Thanks, Andrew. You make an important point of net zero aspect of it. And Lauren, please.
I've got a question from Andrew Holmes. How do we reach the magic target of, say, US $150 per tonne for CO2 removal? Is society willing to pay more if we cannot reach this target? Deanna, I think I saw you nodding. Do you want to have a go at this one?
Yeah, no, that's the salient question, isn't it? It's interesting that, the voluntary market here is playing a very important role. So, for example, we've seen pre-market purchases like Frontier, which are consortia of, some of the world's biggest leading companies, Meta, Facebook, Stripe, Shopify, step into the marketplace and recognising that CDR alongside aggressive mitigation is going to be essential. They have really come together to sort of form, I think Frontier is a $1 billion pre-market purchaser of carbon removal certificates. Of course, we've also got, platforms like Puro Earth, which was purchased by the NASDAQ in 2021 as well. And so these are various trading platforms that recognise that this industry does have to scale, that at the minute, if we're considering some of the technologies that we've talked about in today's discussion, then, at the minute, these technologies are probably 10 to 100 times more expensive than this, target. And Mark actually alluded to the target before. But, we're going to have to get down to, I think the target for the technologies like direct air capture is somewhere around US $100 per tonne. But there are these pre-market purchasers stepping into the marketplace, recognising this. And we have had successes before. We've seen the scaling of the solar PV industry. Here we sit in a time when we're talking about scaling out huge solar resources. I mean, who would have thought that 20 years ago with the costs in the solar PV industry?
Thanks, Deanna. And Mark, a brief comment, please. And maybe I'll also ask panelists, and you can also respond to the questions in the Q&A section by typing your answers as well, considering that we got limited amount of time and we would like to respond to as many questions as possible. Anyway, please go ahead, Mark.
Thanks, Jagadish. I was just going to make the point that it's almost like we need to reverse that question a little bit. And so, for example, imagine a situation where we, say, put a price on carbon of, say, $60 a tonne. That would drive down emissions tremendously. So why would we then go and choose a technology that costs $150 a tonne to do an offset? It's far, far cheaper to actually go down the price on carbon and drive down emissions that way. So we need to be, yes, thinking about the technologies and things, but we also need to be thinking about the policy alternatives here.
Okay, thanks, Mark. And so anyway, but we need to have the reduction of the emissions as well as removal of the CO2. And yeah, thank you. Okay, any next question, please, Lauren.
I think this might be our last question from John Dixon. Mark, which gaps in international networks / platforms could Australia feasibly become a leader in or contribute to? Could you elaborate on mechanisms for the establishment of such a hub or platform?
Well, thanks, John. And I think Andrew probably has a perspective on this as well. So where we look across that spectrum of possibilities that are outlined in this report, there's a whole range of things there, I think, where Australia could step in very productively. And that's because we've actually got a pretty good university sector, R&D sector here in Australia, which can actually play into many different spaces, and not just the technology space, but also the governance, policy and social spaces as well. I would probably say that some of the areas which are relatively well occupied at the moment include the direct air capture side of things. So there's a lot of investment happened in Europe and America and Japan, etc. And so it doesn't sort of seem a lot of sense to go down the same sort of technology paths that those groups have done. But as I think Deanna said, there's lots of other sort of pathways for smart, very energy efficient carbon dioxide capture that we could go down. So as Andrew said before, look at the landscape internationally about what's being done. Don't try to replicate that. Try to actually do stuff which matches our particular circumstances and our capabilities here in Australia. And I think across this spectrum, there's a huge number of those sitting in there, and then they are documented to some extent in this report.
Thanks, Mark. I think considering the time considerations, and probably will close the session here. And first of all, I would like to thank all of you for joining us today and raising many questions. And we are very sorry that we are not able to answer all your questions. And presumably you can stay back, and then maybe the panelists may be able to type in some of the answers to the questions which may be there. And then please have a look at that one. And please also join me in thanking our panelists, Professor Mark Howden, Professor Deanna D'Alessandro, and Professor Jan McDonald, and Dr. Andrew Lenton for such an engaging discussion. And so I also want to remind you that the report is available on the Australian Academy of Sciences website. And also want to take this opportunity to thank Lauren Sullivan and Hugh Olenshaw and our policy and media team of the Academy for working on this important topic. And then we look forward to come back to you with more roundtables on topics of interest for the nation and the people of the country as well. With that, thank you again and have a great day.